let us start our lab of today. Actually, our lab of today is a mix of many things. I will try to cover many subjects. So the first subject is to discuss your assignment. Okay, guys? Okay. So regarding your assignment, I have seen many wrong things done in your configuration. Even though some of you got full mark, while you still do some wrong configuration. But once the ping can be working, I give you the full mark. But if I want to count based on the full configuration together, I shouldn't give full mark, especially when you do wrong thing like using the same IP address twice in the network. If you use the same IP address twice in the network, that means you did not understand one of the basic principles of networks. Okay. Guys, if you want to talk, if you want to interrupt me, that's fine. You can open your mic, you can talk. But if you have noise beside you, please don't open the mic. So anything you want to and you want to tell me or you want to discuss, it's open for you all. So you can discuss freely. Okay, now I'm going to make the assignment here in front of you. So I want to show you what is the correct configurations that we have to do for this example. Oh. Okay, so here we are going to use this Ethernet. So it's not matter Ethernet or gigabit Ethernet, since we are only doing some examples. It's not a real life example. It's not a real scenario. I mean, we shouldn't care about the speed, because we just want to test our knowledge about this concept. Okay, so here is our switches. All of them are connected through the Ethernet to make it easy for us. And the configuration are the same when we use Ethernet or gigabit Ethernet. Only the difference is only the speed of the connection. So here, as you can see, I did not do any configuration yet. I just connect the devices. Okay. Before we start the configuration, I'm going to start up the devices. But I want to explain to you something which is very important to understand. In this scenario, I give you some hints. Last time when I give you the assignment, I told you that you should use the you should do the configuration of the VLAN routing here. Routing. Am I right? So I told you, I give you a hint. Yeah, I told you, you must do the routing for the virtual LAN in the switch 1. Why? Because routing can be done in any place, in any switch. We can make it here, we can make it here, we can make it here. It's no problem. also we can split them. I mean, we can split the configuration among multiple switches. So maybe we can do virtual LAN routing, VLAN routing for VLAN 2, for example, here in this switch, and here we can make it for VLAN 3. Here also we can make it for VLAN 4 maybe and 1 together. It's not a problem. The place is not a problem. But the problem is that when you use the routing, you assign an IP address of the network. Am I right? Guys?
Yes.
Are you with me? You will need to assign an IP address from your network that is later going to be used as gateway. Am I right?
Yes.
So if you assign here 192.168, for example, to 200, how you are going to assign it again here? Is this possible? It's not possible, because you cannot use the same IP address twice in the same place. You are still in the same local area network, because you are here using only switches. You cannot reuse the same IP address more than one time. You cannot. Only one time can be used. So even though if you use this twice, maybe here in the switch 1 and switch 2, it will make a problem at the layer 3. If let's say this switch, for example, switch number 1 is started before switch number 2, so it will take this IP address. Then when switch number 2 start up, and it will try to take the IP address, the same IP address, it will realize that this IP address is already used, so it will see some IP address conflict at the switch 2. But this one is going to affect the layer 3 is not working. This thing actually still will not interrupt the performance of your network. I mean, in terms of using ping, for example, from here to here, or maybe from here to here, it is still working. Why? Because this one is done based on layer 2 here from this switch, while layer 3 is already disabled. Why disabled? Because you already used the same IP address twice. So you have an IP conflict here. Okay? So that's why you cannot use the same IP address twice. For the place of doing the configuration, it's up to you. You can make it anywhere, but don't repeat. Don't repeat the same thing. I saw many of you have configured the routing here and here, and some of them here as well. And the other thing, if you do the routing, the same routing in many places, this will actually is going to make an unnecessary configuration. While, however, it's still working, but it will cost you a lot of time to configure. Then the scenario will become very complicated, and when you want to do any maintenance, your life will become miserable. Then this misconfiguration, it may lead to unnecessary overhead in your network. So it may interrupt the future applications or something like that. So that's why before you do things, you have to write it on a paper. You have to think about it, why I use this, why I put that, why I do this configuration, and so on. Okay, before you start. After that, when you start, you should have a clear plan. Okay. One more thing. Some of you make this ports not equal. So if let's say this one is one link, this, if let's say this one is trunk, this one cannot be accessed. it's not going to work this way. It's not going to work. Both of them have to be in the same time. So either to be accessed, the both side to be accessed, or the both side to be trunk. You cannot use one access and the other side is trunk. So how the switches going to understand, or how they are going to act with it? So if you say this one trunk here, then the switch will send tagged packet. Then the other side will respect untagged packet. So when they read the packet, they feel like the packet is corrupted, then they discard it. So you lose your connectivity in this case. Okay? Is that clear, guys?
Yes.
Okay.
Doctor.
For now, I already started up our what they call it, topology. So now I want to do the configuration for you here. So this one is 192.168.4.1. Am I right? Based on our scenario. And this one we want to use this IP address. I saw some students of you make the configuration, the VLAN routing and everything, but they did not set the gateway. So how it is going to work? I don't know how. I think I already explained this in the class. So this is one of the basic things that we have to do. We already have taken the OSPF, so we already understood the concept of using the gateway. Then I explained also when we take the VLAN routing as well. So you cannot have multiple networks or multiple VLANs that has VLAN routing without using the gateway. So it's not going to work. From VLAN to another, it's not going to work. And also from network to another using routers, it's not going to work without the gateway. So here we have to use gateway 168.4.200, for example. The gateway must be from the same range. You cannot use, for example, 3 here. It's not going to work because this IP address is not accessible to this IP address. You understand what I mean?
Yes.
Yeah, so here we have to use the 192.168.4.200. Okay? So here we have, I want to put the IP address here, 168.4.1. And this one is 192.168.3.1. This one is 192.168.2.1. Okay, this one is from virtual LAN 3. So this one is going to be like this. And this one is going to be like this, 2, 2. Okay, clear? Until now, is it clear?
Yes, Doctor.
Yes.
Yes. So this device, this PC is virtual LAN 2, and this PC is virtual LAN 2 as well. This is virtual LAN 3, and this is virtual LAN 3 as well. This one is the only PC from virtual LAN 4. So here, if you can remember, we have some gateways, gateway for VLAN 1. It's supposed to be 192.168.200. Sorry, this one is VLAN 2. And for VLAN 3, the gateway must be this number. For the VLAN 4, it's going to be this IP address. Okay? So this is our our plan is to use these gateways. We already configured this gateway, the last one here, for the virtual LAN for PCs. Okay, and for the virtual LAN 3, we are going to use the range of the virtual LAN 3. We start with 192.168.3.200. So we already used that gateway, but the gateway is not yet available. Why? Because we not yet assigned this IP address to any interface of our network. Okay, clear?
Yes,
Yeah.
Doctor.
Okay, 192.168.2.1 for this. And 255.255.255, 192.168.2.200 for the gateway. Apply, finish. So here we already done these 3 PCs. Let us continue with this PC as well. So here we have 192.168.3.2 because this one is virtual LAN 3. So 255.255.255, 192.168.3.200. So if you can see here, for this one is VLAN 3 BC, and this is another VLAN 3 BC. So here, if you can see, both of them, because this two is 3.1 and this one 3.2, both of them belongs to virtual LAN number 3, and both of them point to the same gateway. Am I right?
Yes.
Yes,
To the
Doctor.
same gateway, but not yet. The gateway is not yet configured, right?
Yes.
Yeah, okay. So when we configure the gateway, we should configure it in only one place. Only one place. We cannot configure the same gateway IP address in multiple places. This is totally wrong. So if, let's say, we want to configure gateways here in switch number 2, it's going to work. If we want to make it in switch number 3, it's also working. In switch number 4 is also working. In switch number 1 is also working. So it's not a problem, but I choose the switch number 1 because switch number 1 is the middle point, between all switches, all BCs, I mean. Because if, let's say, we want to make a ping from this BC here, BC5, for example, to BC4, the routing will be at the middle here. Am I right? But if we make it here, if we make the gateway configuration here in switch number 2, you see this BC will need very long time to reach the gateway. It's not going to affect too much, but a middle point is better for me. This is my opinion, at least. So it's up to you. If you want to make it here, any place, it's going to work. But the only condition that we have to fulfill is that we never use the configuration twice in different places or in the same network. We cannot configure the same gateway IP address in 2 places. And also we have to make our configuration, as much as we can in the same place, in central place if we can. So it's not a good idea to distribute them in multiple switches, because management is going to be very hard for you. Or if let's say in future you have some problems or you need to do troubleshooting, you will suffer a lot. You will waste your time. That's why it's better to make your things steady and clean as you can in the same place, then everything will be fine. Okay, let us go and configure this. This one is already configured. We configured the last one. Last one is 192.168.2.255.255.255, 192.168.2.200. So You all know that we already configured all of this, but not yet configured any gateway. Okay, so leave this gateway now, the gateway configuration, leave it at the end. Leave it up until the end. After we finish the configuration of our ports to assign them in certain virtual LANs based on our plan, then after that we go and configure the virtual LANs, because virtual LAN routing cannot be done until you create your virtual LANs. So you have also to keep this in mind. So you cannot go and use VLAN F2 without you creating the virtual LAN 2. So you have to create virtual LAN 2 first, then after that you will see, you will be able to get into the virtual LAN, VLAN IF2, because VLAN IF2 is connected or based on the virtual LAN 2. Understood or not?
Yes, doctor.
Yes.
Yeah. So if let's say we have VLAN 2, then we can use VLAN IF2. So this one comes after we create the virtual LAN 2. If this one is not here, this one cannot be used. So sequence of commands, we must create virtual LAN 2 first, then after that we can use virtual LAN IF2. Otherwise it's not going to be working. Okay, to confirm this for you, I can show you now. So let us undo first the terminal monitor, okay, and system. So now if I go to interface VLAN IF2, for example, what it said, the VLAN does not exist. So here we have to create VLAN 2 first, then after that we can go inside the interface of the VLAN IF2. Actually, VLAN IF is the short form of VLAN interface. IF here means interface. Okay, this one is a virtual interface to assign an IP address for VLAN routing purpose. Okay, guys? Here, let us undo the terminal monitor first to avoid the unnecessary logging. So, terminal. Okay, it's only the virtual LAN and virtual LAN routing is only about 5 commands together. You don't need anything more than this. It's very, very simple. But as I mentioned, very simple, but it's tricky. That's why you have to take a paper, you draw your things before you start configuration, because if you start configuration without planning the things that you want to configure, you are going to be lost. So take piece of paper, write your plan, your idea first on the paper, then after that you go and configure. Okay, guys, this must be always in your mind. You cannot do configuration without you planning the things, unless you become professional or expert. In that case, you can do whatever in your mind. But in your level now, you have to take a piece of paper, write the things cleanly. Then after that, after you finish, you start implementing the things. Okay, guys?
Yes, doctor.
Okay, let us do the configuration now. So here let us take the switch number 1 first. So what we want to do, how many virtual LANs we want to do? We want to configure Three virtual LANs. Some of you have had make this link here as a trunk, but they allow only traffic of virtual LAN 3. So in this case, traffic from virtual LAN 3 is going to be delivered here. But if, let's say, BC number 1 wants to ping this BC, it's not going to be accessible because we did not allow virtual LAN 4 and virtual LAN 2. So in this case, if we want to let all virtual LANs to communicate each other, then these 3 links must allow all virtual LANs traffic. We cannot allow here 2, 3, and 4. And in this one, we allow only 3. And in this one, we allow only 2, virtual LAN 2. So in this case, the networks will not be able to communicate to each other. Okay? Only this part, many of you have configured this to allow traffic from all networks or all virtual LANs, but this one is only allowing virtual LAN 3 and this one allows virtual LAN 2. So in this case, only these 3 PCs can communicate. And from different virtual LANs, I mean, they can communicate because they belongs to this switch. But this PC can communicate only with this PC. This PC is only can communicate with this PC because they belongs to the same virtual LAN. Okay? Okay, let us do the configuration now for switch number 1. So before we start, what to do? Before we start, guys, the first thing, before we configure virtual LANs, what to do? VLAN patch 2.4, am I right? To create our virtual LANs. So we created virtual LAN 2, 3, and 4. You can see display VLAN. Actually, display can be written also in the short form like this, VLAN. So it will display you virtual LAN 1, 2, 3, and 4. Okay? So after we created the virtual LAN, now what to do? The second thing, we have to go to interface Ethernet 001, and we assign or we change this port to link type trunk, is it? And after that,
yes,
we use port trunk allow pass VLAN all. Because I don't want to write 2, 3, and 4. It's easy for me to write all, is it? Unless I have other networks that I don't want them to be accessible or to use this link. So in that case, I maybe list my my virtual LANs like 2, 3, 4, for example, 9 and 11. Maybe I don't want the number 10 to use this trunk. Okay, in that case, we have to list them. But in our case, because we don't have other virtual LANs that's not needed to use this trunk, in this case, we can use all. So that's all about the first port. So we go to the second port. We put it also in the trunk mode. We allow all traffic. Then we go to the third interface. We change its type to trunk. Then we allow all virtual LANs to pass. Is that hard?
no,
Very simple, is it? Very clear. Okay, so here we're done with the switch number 1, but the thing that we need to do here in switch number 1 maybe, or in switch number 2, it's up to you, is the VLAN routing configuration. I will leave this until the end. Okay, so let us now go to switch number 2 and configure the VLANs. So the first thing we do, we VLAN patch to Then after that, we go to interface Ethernet 001, which is this here. So this one must be a trunk. Am I right? So port link type trunk. Then this one is going to be allowing also all traffic from all virtual LANs, like this. Okay. So this one is trunk and allow all. This one is trunk and allow all. So these two sides now can communicate, can understand each other. We cannot make this allow all and here only we allow, for example, virtual LAN number 4. In this case, there will be a wrong configuration and many scenarios is going to be failed. Okay. So we finished the trunk configuration. Let us now configure these 3 access interfaces. So we need to go to interface number 2. We have to make it access. The link type is access for the port. And this one is later port default is going to be assigned to virtual LAN number 4. Correct? Then Ethernet number 3, it's also going to be set to access, and this will be assigned to virtual LAN number 3. And after that, we go to virtual LAN number 2. Sorry, virtual LAN number 4. And this is also is an access port, and it's supposed to be assigned to virtual LAN number 2. Here we finish the configuration of switch number 2. Let us go to switch number 3. So here we have to create how many virtual LANs we need to create here?
1,
What is that?
3, VLAN 3.
Why we don't need to create VLAN 2 and VLAN 4?
Because the available VLAN for that switch, under that switch is only VLAN 3.
Only VLAN 3, but if the scenario is like this, if it's possible to connect some PCs belongs to other virtual LANs to this switch, in this case we have also to create the virtual LAN 2 and 4. But if let's say we have only this PC and this is the only PC that will remain connected to this switch belongs to virtual LAN 3, in this case we create only virtual LAN 3. Okay, only virtual LAN 3, and we quit after that because here we are not going to configure any virtual LAN routing. Am I right? But if we want to configure the virtual LAN routings, all of these gateways here in the switch number 3, for example, in this case we have to create all of these virtual LANs. Okay, so it depends on how you want to make it, how you want to make the configuration. So here, what we want to do is to go to interface Ethernet 002, and we assign the trunk port link type trunk, and port trunk allow pass all. Oh, sorry, I forgot VLAN. Okay, and after this we have to go to interface number 1, which is connected to the PC down there, and we have to use the port link type access and port default VLAN 3. Done. Okay. Now, what we want to do is to go to switch number 4, and we create VLAN 2, quit, then interface, Ethernet 3, sorry, 0, 0, 3. So this one is going to be set to port link type trunk, and port trunk allow pass VLAN all. So sorry, I want to undo terminal. Okay, so here we go to interface number 1, then we assign it the access rule. Then after that, port default VLAN 2. Okay, here we are. So now our configuration is already done. Okay, what if now, if we want to ping from here, from BC 3.1 to, for example, ping 192.168.3.2. It's working, is it? Are you still with me, guys?
Yes.
Yeah, it's working. Why working? Because this one is going from here, from this PC to this PC. So this link allows traffic from virtual LAN 3, and this one also allows traffic from virtual LAN 3. So here they can communicate. What if we want to ping 192.168.2.1, which is this, the one that's connected to the same switch here. So can we do ping like this? Can we?
Yes.
Yes.
Yes or no?
Yes.
Yes.
No, we cannot. You see, destination host is unreachable. Why unreachable? Because this one is different network, am I right? Different network. So when we want to communicate from network to another, we have to enable the gateway. We have to go through the gateway, and the gateway is not yet there, is not yet configured. So here we cannot do ping. The network is unreachable. Also, if we ping the 4.1, this one, PC number 1, it's also inaccessible. But if we go to PC number 2 here, and we try to ping the other PC from the same network, it's going to be responding to 2. You see, it's working. Why? Because from here, from this PC is to this PC, this one allows traffic from network number 2, and this one allows traffic from network number 2. So they can communicate because they are still in the same network. They use the same range of IP addresses, right? But they cannot communicate. I mean, from here, they cannot ping other PCs belongs to other networks. You see, the same thing, destination host unreachable. So to allow this until this time, until this moment, we have already configured our virtual LANs, and our network splits the groups from each other. So we split we divided our main domain, broadcast domain into 3 broadcast domains. Am I right? But if, let's say, the requirements of the company, as we have in our assignment, is to allow PCs from different virtual LANs to communicate to each other. So in this case, we have to do some routing. Okay? So here, in this switch, if we go, let us undo first, undo terminal. Every time we have to do it, otherwise we will see a lot of logging. Terminal monitor. So here, before we do the configuration of our gateways, the 3 gateways for virtual LAN 2, virtual LAN 3, and virtual LAN 4, we have to make sure that our virtual LANs are already there. So we display VLAN, they are already configured, but I want you only to remember that we already configured virtual LAN 2, 3, and 4. So here we can assign for them some IP addresses. Am I right? So here we can go to switch number 1, and we can go to interface VLAN IF space 2. So for network number 2, what is the gateway? Gateway must be IP address, must be 192.168.2.200. Am I right? With the prefix 24. So that's all. So now our network 2 is already configured. The gateway of virtual LAN 2 is already configured. It's only configured one time. We don't need anything to do other than this. After this, we go to interface VLAN 3. We assign an IP address for virtual LAN 3 for the gateway 3.200. And after that, we go to virtual LAN number 4. We assign an IP for the virtual LAN gateway, virtual LAN number 4 gateway, which is 4.200. So now everything is done. If we go to BC number 4 here, BC number 4, and we open the command, then we ping 192.168.3.1. Last time it's not possible to ping them, is it? Because they are belongs to different networks, but now we can. Okay, this one works. What's about 2.1? It works. What's about 2.2, which is connected to other router? It's also working. Okay, what's about 3.2, which is also connected through other switch? It's also working. Here we are, here we're done. We have nothing to do more than this. It's only 4 commands that you want to repeat here and there. That's all. But your plan must be clean, must be clear. You cannot repeat things only like that because you think that we have to use VLAN IF in every switch. It's not like this. We use things only when we need. So if we misconfigure, the network will become miserable. Our users will be dissatisfied. So if we are working in a real network, they will kick us out. If we do the first configuration or the second configuration, they will see this satisfaction from customers or from users. They will think about what happened to this guy. You cannot do this kind of misconfiguration. You have to be clear. You have to be clean. You have to have your plan before you start. Otherwise, you are not going to succeed. You always put this in mind. It's an easy style of working. Take a piece of paper and then write your configuration on the piece of paper. Think about everything you do. Then after that, after you finish, you implement. If you implement, then things is not working, go to your piece of paper, make sure that everything is implemented as you planned in the paper. This is the first thing. Then after that, if the thing's still not working, then you go to the paper, think why the thing's not working. Okay, after you can find the solution, then you can go and modify your configuration. But if you go to the devices directly, you start configuring here, there, and in many places, then things is not working. You will feel like disappointed and you will lose your control. Then you will forget what configuration you have done in every PC or in every router, then the problem will start. Okay? Okay, guys, clear?
Yeah, doctor.
So please, as I mentioned again, before you start, piece of paper and pen, draw your things first, then you start configuration. Okay, agreed?
Yes.
Okay.
Yes.
So this is the scenario of our assignment. Unfortunately, our assignment is not acceptable in the system. As you can see, I can show you here also in the system. It's or maybe this will show you the marks of your colleagues. That's why. Just forget about it. I'm not going to show you because of some of you have submitted very lately after 12 p.m. that night, and I couldn't submit the marks for some of you, and the others are going to take 0. That's why we lost the opportunity. So we did this effort together. I wasted the whole of my day waiting for you, but unfortunately we couldn't make it. Anyway, that was a very good opportunity for you to implement the virtual LAN and virtual LAN routing, and we still need to use that understanding or that knowledge that we have gone through during our assignment number 1. So I'm going to modify actually some things, because we here in our course description here for the assessment, we have test 1 is already done, and we still have mini project and lab, and also we have the oral. So for this, it's together 40%. Am I right? This one is 40%. So 40% is very, very important for you. Okay, I don't want you to lose these marks also. I want you to give it enough time to take it seriously and to submit before the deadline, because now in this time, I'm not going to wait. I'm not going to consider any late submission after the deadline. If you submit after the deadline, you are going to take 0. If you don't care about yourself, why I should care about you? Is that correct or not?
Yes.
Yeah, I really care about you all. But if you don't care about yourself, why should I care? I shouldn't consider any submission after the deadline. Okay, guys? And for this 40%, actually, we are going to use this mini project for you to get the 10% of the project. And also, I will consider it as a lab together with the assignment, the previous assignment. And for the oral, I want you to do the presentation about your mini project, record it, upload it to the Butrablast. Okay, guys?
Okay, doctor.
Okay. So this scenario, I'm not going to create a new scenario for you, but I'm going to insert something here because this one must have some work also. And also here we have another PC here and another PC here. And we will have other switch here. that's connected to other PC here. Okay. So I'll give you some hints, but I'm not going to repeat because I feel like I repeated too much for you last time, but you some of you did not care, or maybe did not take it seriously. So here we have another connection to this, and from here to here, from here to here, and also and what I want you to do is to make this from 192.168.4.2, and this one is 192.168.1 to sorry, to 3, and this one 192.168.4.3. Okay, so from here we added 2 PCs. We inserted 2 PCs to VLAN 4, and we inserted 1 PC for VLAN number 2 here. So this one, and that one will be belongs to the same network. Now, what I want to do, what I want you to do, I want you to delete your assignment, your previous assignment, delete it, or save it in different place, and you start a newly fresh topology, new fresh topology, and you start the configuration as I just explained to you. Step by step, before you start the configuration, you draw the things, you configure your PCs, you make sure that you don't have any conflict of the IP addresses. So every IP address is used one time in the network. And after that, you go to your switches, you configure all of the ports, the access ports and the trunk ports. When you start one switch, don't go out from the switch until you finish. So you take the first interface, configure it as a trunk, allow all, the second one access, assign it to a certain virtual LAN, the second one, the third one, the fourth one, until you finish. Then you go to the next switch. Okay? After you finish the configuration of your virtual LAN, you test that every PC belongs to a certain virtual LAN, can ping other PCs from the same virtual LAN. If you achieve this, that means your VLAN configuration is already correct. So after that, after you make sure that the VLAN configuration is correct, so every PC belongs belongs to a certain virtual LAN, can ping all members of the virtual LAN, then you can go forward and do the configuration of the gateways of the virtual LAN routing. Okay. I was planning to add one switch here, and after one router here, and after the router I want to assign one PC here. Then I want to make a connection like this from here. I don't know what happened to this. So from here to here, then another connection from here to here. Then I wanted to make this like 1, 1, 1, 1, then 8. Or I make it clear, /8. So this one is going to represent the internet. So I wanted to use this configuration. So for this router, you have to assign or you have to configure routing protocol, for example, OSPF or whatever. And also here for this link, because this is a router, so this interface must take an IP address, and this IP address must be set carefully. And also, in order to use this IP address and to get reach to this PC, you have to add some routings here. You have to add some routings. So if, for example, this one is 192, for example, I will put some annotation for people who are interested to understand. So you still can do it. So for example, this one is 10.1. Okay. So definitely this side is going to use the same IP address range of the BC number 9. So here, the IP address here must be something like 1.1.1 and, for example, 2, because this one and this one must be from the same network to reach each other. Okay. So from here, from all of this network here, okay, all of this VCs, they're supposed to access VC number 9. Am I right? So in this case, they have to access different network, while the R belongs to other networks. Am I right? So in this case, they have to rely on a gateway. They have to rely on a gateway. So their gateway is already configured here in the switch number 1, but this switch number 1 doesn't know about the existence of this network 10.1 and also the existence of network 1.1.1.2. These two networks are not known. So in order to get knowledge to this network, actually, we have to get accessibility to router 1. So in order to access router 1, we have to teach our gateway here in the switch number 1 about this network. So we have to have another IP address here in this switch, for example 200 here, to identify this network. Am I right? So maybe we need to add this as gateway also for the network 10.1. So this one is going to be, for example, gateway, and we still need to use virtual LAN. So virtual LAN, maybe 5, maybe. It's just a hint for you. Okay, I just want to give you a hint to understand how to configure it. Then if we assign this port to virtual LAN number 5, then what we have to do is that we need to consider that virtual LAN in all of these switches. This is one solution. The other solution is to check, before we do the configuration of the virtual LAN, we apply the OSPF, for example, here in this router. Then we check the routing table. If we found these networks inside our routing table, that means everything is going to be fine. Okay, guys?
Okay,
Doctor.
doctor.
Yeah, but the only thing that you have to be careful about is this link, the link between switch 1 and router 1. So this one, if you make it virtual LAN, then you are going to have some complexity in your configuration, actually. That's why I don't advise you to use virtual LAN for this part, but I want you to be creative. If you can make this part, and you make this PC accessible for the whole network here, I will give you bonus marks. I will give until five marks bonus. Okay, so this part, the router 1 and BC number 9 is, I mean, optional. It's up to you. If you want to do it. Then if you make it, I give you extra marks. If you don't want to make it, okay, just forget about it, and you only will get marks about what you have done. Okay, guys?
Okay,
Is
doctor.
that clear? Okay. So this part can be used for students, especially students who did not achieve good marks in the test 1. So you can get 5 marks for this, for the router 1 and BC number 9. Okay. So until here we have configured everything. So I want to save. So to save your configuration in your PCs, I'm going to explain to you now, because some of you doesn't know how to save and doesn't know how to share the files and so on. So if you want to save, sorry. If you want to save your work that you have done, you have to go into every switch that have some configuration, and you have to be in the user view, and you have to run the command save. Then after that you hit TS, Y, and enter. Then after that you have to hit another enter, like this. Then you can see the save the configuration successfully. Okay, we go to the next switch. We run the command save also, Y, enter. Also saved. And here also we run the save command, Y, enter, saved. And for the switch number 4, we run the save command, Y, enter. So we saved all of our switches that we configured. For this switch number 5 and switch number 6 and also router number 1, we did not do any configuration, so we don't have to run the save command. Also for PCs, if you configure a PC and you click on the apply button and you close like this now, you did this configuration, then you press the apply button and you close, that means the configuration is already saved. So here we already saved all of the switches configurations, but we still did not save our topology. So in order to save our topology, we have to go to the save button here. Okay, you can see this.
Yes.
So we click on the save button here and we hit, or we enter the project name, for example, lab test, and we put it in a certain place. I prefer to use my own folder here that I created in the course. So I must know where I saved the topology and everything. So now everything is saved. We just switch off the things. Then after that we close. Okay, after we want to close, it will ask us about this. Do you want to save lab test topology? It's already saved, but no problem. You just hit yes again, and it will save again. No problem will happen. Then we have to go here, and we have to go to our folder. Then we will see our folder created for our project here. So this one will contain the topology file. This one is the topology file. Some of you send me only this file. If you send me only this file can open and show the devices that you put in your topology, but it doesn't show the configuration. I cannot find the configuration because the configuration is saved separately. We have 4 switches. For every switch, we have a separated folder here. Okay, don't play with this. Here is the configuration actually of the switch. So don't play with this. You just, the thing that I want you to do is only to take this folder like this, make it in a ZIB or RAR file like that. Send me this file. Clear?
Yes,
Okay,
doctor.
Okay. No need to save configuration in separated folder file or send them to me. No need to do all of that stuff. Yeah, you just follow this this behavior. Okay, now we'll take 5 minutes. If you have any question in this regard for the virtual LAN and virtual LAN routing, is there anything unclear?
Doctor, for the mini project, will you upload the instruction?
Yeah, I will upload. Yeah, because we don't have enough time. We have to make it quickly before I will set the date for that.
All right, doctor.
And for your information, you don't have to do much. Actually, it's very easy. I can sit for 10 minutes. I can finish it, or maybe less than 10 minutes. I can finish this this lab, and I can get 40 marks. 40 marks is not 1 or 2 or 10 marks. It's 40. So if you can achieve this, you will guarantee that you will pass this course. Otherwise, you may see me next year, maybe, or next semester. I don't want to say that, but I was upset about the assignment. Anyway, I don't want to look back. We already have passed that assignment, and I want to forget about it. And this is another opportunity for you to achieve good marks, to improve your result. So please take the opportunity. Don't waste it. Be responsible. Take it serious and submit before the deadline. Okay? So now if you don't ask, I will consider that everything is clear and we have no problem with the virtual LAN and the virtual LAN routing. Okay, now we still have 45 minutes. I want to utilize them for the STP and RSTP. Okay, guys. Things are very simple, very, very simple. So if for example, if we want to take anything, for example, virtual LAN. Okay, if let's say we want to take the virtual LAN and we want to implement some scenarios. So you can see here how many slides we that have commands. Only this, this, and this. Right? So it's very little, very little. So this one has how many commands? This is the command of creating the virtual LAN. Is only one command to create, or 2 commands to create virtual LAN. So you can write them in a separated paper or in your notebook. And also this is the command to display the virtual LANs. This is very simple. And this is other command to assign link type for a port, and this is the other type of the port. And also the other command here is still the same. create virtual LAN already known, and this is an access assignment of access rule to the port and assigning the port to a virtual LAN. And also here we have the display is repeated command, and also here we have the same commands. So only this this one is another way to assign a certain port to virtual LAN. So either to use this command or to use what they call it. This one is actually to assign the trunk port to a virtual LAN, to a certain virtual LAN. Okay, and this is to allow pass. And after that, another command here is repeated. This one is also not new commands. Only this one is only for hybrid. So we can configure virtual LAN and virtual LAN routing without the use of hybrid. So it's not that hard thing. And also, if you want to understand about the hybrid is also easy. So the only thing when you need to assign a port using hybrid for an end system, you use untagged. But for trunk links, you use tagged. That's all. It's exactly the same. Okay, so we don't need to think about it in a bad way. It's very simple. If we consider the STP, for STP, for example, here, we can go and check our slides. All of our slides doesn't have commands here. So here we have, in this slide, we have only one command. In this slide, 2 commands. Command number 3, command number 4, command number 5, and command number 6. So STP is only 6 commands. You imagine this? Only 6 commands. So is it hard to learn? Is it hard to configure? Is it hard to remember? It's not hard to remember. It's not hard to configure as well. Okay?
Yes, doctor.
Okay, doctor.
So please don't make it hard for yourself. Try to take your notebook. Try to take all of the commands. For example, you write the title STP, then you write all of the possible commands that you have in the STP. Then put it in front of your face while you are doing the configuration to avoid any mistakes until you remember them. But for your final exam, you have to remember them as your name, as you remember your name. Okay? Because we will have some questions to ask you do some configuration. So here, let us consider a new topology, and let us take some switches, or maybe 3 enough. Then let us connect them. Maybe maybe we need to have redundancy like this, and also maybe we create another connectivity here. Maybe other switch like this, other switch like this here. And this switch is connected this way. Okay, so Okay, this one. Okay. Now, if we want to run this switch, so all of these switches are going to be using the MSTP by default, multiple spanning tree protocol by default. But we, for the purpose of learning, we want to downgrade that protocol to the STP for all of our switches. So here we undo terminal monitor first, then we go to system, and we can display STP. Okay, you can see we did not configure anything. We display STP, and you can look here, and somewhere you will find the MSTP is enabled. You see, mode is MSTP. So by default, Huawei switches implement the MSTP without any configuration. Okay, the thing that we want to do is to go here and use the STP mode command to change to STP. Instead of MSTP, we want to change to STP. Okay, done. If we repeat the same command, display STP, you will see that the mode is already changed to STP here. Okay, is that clear?
Yes.
Yes.
Okay,
Yes.
okay, good, good. So now we do the same thing here. Undo terminal monitor, system, then STP mode STP. Is that hard? No.
No.
Okay. Undo terminal monitor, system, STP mode STP. And also for the fourth one, undo terminal monitor. I think I have to copy this. Every time I have to repeat it. Okay. System STP mode STP. Okay. So here we are. We already changed all of the switches to STP mode. So now if we display here, if we display again, let me quit here, and we display STP. So from here we can see, we can read one by one. So CIST bridge is this, config times is this. So we can see the hello timer is 2 seconds, the maximum age is 20, and and the maximum hop is 20. Why the maximum hop is 20? Because the maximum age is 20. Okay, so the age is going to be minus every time we travel through one switch. So every switch, before it forwards the BBDU, it will reduce the message age by 1, or will increase the message age by 1. So when the message age exceeds the maximum age, then the packet will be considered invalid. So here we can see the ERBC. It's 200,000, and what else? Root port ID, It's 128.2, and also BBDU protection is disabled. TC or TCN received is 71 until now, and here is STP coverage mode is normal, and you can read everything here. Also here, port protocol is enabled, then designated port rule is this one, okay? From here, I will write the annotations here. So port 1 here is designated, right? What's about the priority? Port priority is 128. Port cost is 200,000. You see, so every port has some costs. Every port. Okay, then if let's go to the other thing, other interface. So this one, interface number 2, it's root port. Root port. So here, this one is R. So can you tell me whether switch number 1 is a root bridge or not, based on this information? Switch number 1, is it root bridge or not? Hello? Is it root bridge or not? It's not a root bridge. Do you know why? Because it has an R port. R port means this is the port that connects the switch number 1 to the root bridge. So maybe switch number 2 is the root bridge, maybe. Or maybe switch number 4, because if the connection is like this, that means this port is the root port that's connecting the switch number 1 to the root bridge. So root bridge, all ports must be set to designated port. Okay, so we check the port number 3. Port number 3 is alternative. Okay, so here we are. We add the annotation here. This one is A. Okay, what's about port number 2? So display STP. Port number 1 is designated. So we put port number 1 is designated. Port number 2 is also designated. Port number 2 is also designated. And port number 3 is also designated. So it seems that switch number 2 is the root bridge. So I just want to explain in this simple way to let you understand how it's working. So switch number 4, port number 4 is also designated. So from here, based on this information, switch number 2 is the root bridge. Switch number 2 is the root bridge. Actually, you can find it somewhere here at the beginning of the display STP command. So somewhere you will find that this this switch is a root bridge. But anyway, anyway, maybe it's not clear here. I think, if I'm not mistaken, there is another command. Control C, STP, display STP brief. Yeah, this one is a brief display for the STP. So you can see here all of the ports of switch number 4, switch number 2 are set to designated ports here, and their state is forwarding. and the protection is not implemented. Protection is not implemented. So what's about switch number 1? If we run the display brief command, so here we can see port number 1 is designated, port number 2 is root. Root means it points to the root bridge. And port number 3 is alternate, as you can see here. So let us go to this STP brief. So here, port number 1A, port number 2A, port number 4 is root. So this one is A, this one is also A, sorry, A, and this one is root port. Okay, what's about switch number 4? Switch number 4 is to display STP brief. We have two interfaces. Number 1 is root and number 2 is designated. So this one is R and this one is designated. Okay, let us see here. So for this redundant links, you can see that the switch number 1 selects the Ethernet 002 to be the active port. So this link connected to interface number 2 is active, but the link connected to the interface number 3 is an alternative. Alternative, that means it's inactive. So it will be active only if this link is disabled. So if we shut down the interface number 2, interface number 3 will change directly to R. Okay, let us consider that scenario. We go to interface number 2, 002, and we run the shutdown. Okay, so here we already shut down interface number 2. Oh, it's wrong. This one is interface number 2. We wrongly put the notations. We wrongly moved the notations. As you can see, this one is red because it's already shut down. Last time, this one was active as a root port. But now, if we go to switch number 1 and we display the STP, we can see that port number 2 is already not there. It's not listed here. And port number 1 still D because it's not affected. The only link between these switches is here. And the port number 3 is set to root. So now this one is R. Why? Because this one is already failed. Okay, is that clear, guys?
Yes, doctor.
Yes.
Okay. What if we undo shutdown? Undo shutdown. We undo shutdown here. As you can see here, Ethernet number 2 is already green. So if we display, what happens? Number 2 already get back to root. Because why? This one, number 2, is always root when both of them are working, because this one, these two interfaces has the same priority, and both of them has the same cost. So now, which one is going to be selected is the one that has a smaller interface number, smaller port ID. So that's why Ethernet 2 is going to be used before the Ethernet number 3. Okay, clear?
Yes, doctor.
Yeah. Okay, let us now draw the spanning tree of our network. So our spanning tree, actually, this links that you have seen here in this topology actually is the physical links, but virtually the spanning tree protocol will create its own spanning tree. So it will start with the root bridge, which is switch number 2 at the top. Then it will go directly to switch number 1 and switch number 3 and also switch number 4. Okay, so okay, here the active links now between switch number 2 and switch number 1 is based on interface number 2. Am I right? Interface number 2. And number 1 is not considered here in the spanning tree because it's already alternate. The interface number 3, this one, because this one is already alternate. So we are not going to draw it in our spanning tree. Okay, what's about the link between switch number 3 and switch number 2? It's based on this port, am I right? So here
Yes.
it's port number 4, port number 4. So what's about the switch number 4? It's based on this port. It's
So,
interface number 1,
1.
interface number 1. Okay. What's about the other links like this and like this? These two are inactive along with this one. So we have 3 links inactive. So our spanning tree now currently is this, as you can see here. This one, our spanning tree, our active spanning tree. So all of the switches connected to the same STP network, they will have the same copy of the spanning tree, the same copy. So switch number 4 knows that switch number 1 is accessible only through the switch number 2. So directly, if any traffic comes to switch number 2, it will be forwarded to switch number 1. It will be forwarded to switch number 2 immediately. Okay. What if I will delete this now? Before I delete, do you have any question?
No.
Okay.
No, doctor.
No, doctor.
Okay, I delete. So now what if we shut down this switch number 2? We shut down switch number 2. So what happens here? We lost all of this connectivity, am I right? So what if I go to switch number 3 here and I display brief? So one port is designated, port number 1. This one changed to D. And the other one is changed to R. Okay. This means switch number 4 actually is the root bridge. Let us check this. This one has only one port, this one, which is R. So R means the root bridge is on this port, connected on this port through switch number 3. If we go here and we display brief, we can see that we have only one port and that port is designated. That means this switch is the designated, the root bridge switch. So our topology now is like that. Our topology now is like this. Our spanning tree. So this one is switch number 4. This one is switch number 3, and this one is switch number 2. You see how it's changed. So depends on the topology change. The spanning tree is going to be changed. Okay, clear?
Yes.
Yes.
Okay. So what else we have to do here is to understand how to play with the priority. So let us return this back. So if we return this back, I want to return all of the annotations. Okay. So it's already started up, and now what we want to do is to undo terminal monitor, then system STP mode, because now it's already returned back to the MSTP, and because we already shut down the switch. So we return it back to STP, and if we want to display STP brief, we can see that all ports are set to designated. That means switch number 2 is selected as the root bridge. So what if we want to make switch number 1 is the designated switch or the root switch? What if we want to make the switch number 1 as the root bridge? So in this case, we can do many things. We can play with the priority. We can assign the root bridge. We make the switch as a primary. So here we have some command here. We have some commands here. If you can see here. I don't know, where is it? So maybe in the comments down there, display STP, and here is to make the switch primary. Yeah, this one, STP root primary, STP root primary. Okay, so this is the command. So if, let's say, we want to make switch number 2 as a main switch. So we go to switch number 2. We make sure that we are on the system view, not inside any interface. Then we use the command STP root primary. And also we can use STP root secondary also. So we can use primary, we can use secondary. So we can give the priority for example, for switch number 1. If switch number 1 has a problem, maybe we move to a switch number 2, for example, or switch number 3. Okay. So let us go to switch number 4, and we assign it as root primary. Okay. Then if we display, you can see here that now switch number 4 become the designated root bridge. So it's designated root bridge now. Okay. So number 4 is the root bridge primary. Okay. If we want, for example, to make switch number 1 as the root secondary. Okay. So now if we display here, this switch is not the root bridge. Why? Because it has one root port and other two ports as alternative. So the root port is number 2, this one, and this one is alternative. This one is alternative. Okay, and this one, both sides are designated. This one D, and the other one here is D. For this one is going to be the R, and this one is designated, because one link must have one side as D. So this side is R, the other side is easily to be D. If this side is A, the other side is definitely will be D. But this one, I think it can be alternative. Let us check now, switch number 2, if we display. Oh, this one is also D, that means this side is A. Okay, and here this one is alternative, this is designated, this one is root, that's all. So if we want to confirm, if we go to switch number 3 and display brief, so we can see port number 1 is designated, port number 2 is root, port number 3 is alternative. Correct, as we expected, exactly. So for switch number 2, root is this, number 1. Number 2 is designated. For switch number 1, alternative, and root. So here our spanning tree actually is like this. For switch number 4, then switch number 4 is connected to switch number 2 using port number 1, and here port number 1, and it's also connected to switch number 3 using the port number 2, and connected to switch number 1 using the interface number 2. This is our spanning tree. Now, this is our active spanning tree. So why this happens? Because we make this switch number 4 the root primary, am I right? And switch number 1, we make it root secondary. Correct? So what if we go to switch number 4 and we go to interface number 0, Ethernet 001, and we run the shutdown. We go to interface number 2 as well, and we run the shutdown command. Okay, now this switch is failed. Am I right? The root bridge is already failed. So what if we go to switch number 1 now and we check display brief? We can see automatically that the switch number 1 is changed to be the root bridge when the primary root bridge failed. If the root primary is failed, the secondary root will take over and will become the root bridge. Okay? Is that clear, guys?
Yes.
Yes.
Okay. That's good. This is one thing. So let us now go and undo shutdown here for port number 2, and undo shutdown also for port number 1 to return things to normal. So here, if now switch number 4 returns back to the normal situation, and it becomes the root bridge. Okay. other thing here, if we don't want to use the primary command, so last time we use STP root primary here, am I right? STP root primary. So what happened? Okay, it seems like this. Undo STP root. So we undo the STP root primary. So if we display brief now, we can see that the switch number 4 lost its mode as a root bridge, because last time it plays as the root bridge because we said that this one is a root primary. Okay, now it's not root primary. So if we can check here switch number 2, then we will see that the secondary one should take over. So now the secondary now become the designated. But what if we also undo root? Undo STP root. So in this case, if we display, we can see that it has designated root alternative. That means switch number 2 returns back to be the root bridge. Okay, now switch number 2 become the root bridge. Okay, we learned how to control which switch we want to make it primary and which switch we want to make it secondary. Also, we can play with that using different way of configuration. So if we go to STP priority, and we make it like 4096, okay? Because the default priority for STP switches is 32,000 something. So 32,000 something is lower priority than 4,000. So now we want to make switch number 4, for example, sorry, not this one. We want to, for example, we changed. If let's say we changed our plan and we want to make switch number 3 as a primary route. Okay, so in this case we can use the STP priority 4096. Okay, so if we do this and we run brief, we can see that immediately switch number 3 become the root bridge. All the ports become designated. Okay, so what if this one is failed? If this one is failed, the second priority will take over. The second priority switch will become the root bridge. So if we switch off this switch number 3, definitely switch number 2 will take over the root bridge. Okay, is that clear?
Yes.
Okay, what else do we have? We have something called the path cost standard. So if let's say we want to change our path cost STP path cost standard. Here you can see how many options do we have? We have 3 options: .1D and .1T and legacy. .1D, as I mentioned, is the standard of Cisco, and .1T is the standard of Huawei, and the legacy is the default standard, or the first standard ever that's shared among all of the vendors. So this one is enabled by default. But sometimes, if let's say you have a mix of devices from different vendors, for example, you have one switch from Cisco, other switches from Huawei, then maybe 5 or 6 switches from Cisco. So the number of Cisco switches is bigger than the number of Huawei switches. So it's fair to go to the Huawei device and change it to be compatible with the Cisco device. So maybe you will need to go back to .1D standard to get compatible with the Cisco. Otherwise, you have to go to all of the Cisco devices. Then, if possible, you change them to use the .1T, but that .1T is not supported in the Cisco devices. That's why in most cases you have to configure our Huawei device to the standard of Cisco. If the standard of Cisco has an issue, then you may modify the costs manually, which will make for you a lot of headache. Okay, so this is one thing. So if we want to display or to change the standard, then we easily write .1 like this, .1T, for example, and hit enter, or maybe .1D and hit enter. So it's up to you what standard you want to use, but make sure that all devices are using the same standard. Okay, for the what else? For the root protection, actually we have the root protection. So root protection command actually is going to be configured to a certain ports. For example, if you go to interface, then you mention Ethernet 00, for example, 4, this one, or maybe this one, port number 1. If you want to make a root protection for this port, so you can run STP root protection and hit the command, hit the button enter. And here the root protection is already enabled on this port. Okay, so this is how to enable the root protection. And what else we have? The cost, the port cost. So maybe if you want to make to assign different cost for this port, for maybe for port number 1, then you can use, you have to be inside the interface, and you can change the cost like this, for example, to 20,000, for example. And depends on this cost, the selection of the alternative links will be decided. So let us take one scenario for this, because we already have, I want to undo the cost, and we also want to go to switch number 3, and we don't want to make it designated, so we want to undo the priority, undo, to return everything as the default configuration. So here it switch number 2, I think now is the designated STP or display STP brief. Yes, switch number 2 became the designated root bridge. So what's about this one? Display STP, switch number 1, brief. Now, as you can see here, the port number 1 is designated, and the port number 2 is root, and port number 3 is alternative. So what if we go to interface, Ethernet 002, the one that's now set to root port, we want to give it an STP cost, like very big cost. Okay, so now the cost of port number 3 is cheaper. Am I right? So if we go back here and we display brief, then we will see that the port number 2 become alternative and port number 3 become root. Is it? Is it clear?
Yes, doctor.
Yeah.
Yes.
So this is how to play with the configuration. This is how to decide what link is active and what link is alternative, and which switch is the root bridge and which switch is the backup root switch, and when you want to apply the BBDU protection or root protection or maybe loop protection, it's up to you. You can use all of these configurations in all parts and all switches. So we still have another command to display STP for a certain interface. For example, Ethernet 002, for example. So here, let me clean this. So here, this is the interface 002. So as you can see here, the bridge, and this one is the port number 2. Okay, port number 2 mode is set to discarding, and port protocol is enabled. The situation is the status is alternate port, and the priority is 128. The cost is like this, the one that we configured. You see, it's already changed to this big cost. And also, you can see a lot of other things. You can see here the protection is none. Also, port STP mode is STP, and so on. So what if we want to go to that interface Ethernet 002 exactly, then we want to use STP loop protection, STP loop protection. Then we use display STP. Yeah, here you can see, oh, it doesn't show. Oh, sorry, because this one is STP. STP doesn't have loop protection. STP doesn't have loop protection. It has only the what they call it, root protection. Error failed to enable the root protection because the loop protection is enabled. Oh, so loop protection is enabled. So if loop protection is enabled, root protection cannot be used. Am I right? So do you remember this? Did I mention this in the class? Definitely yes, because I mentioned that in every pod, if you implement the root protection, you will not be able to use the loop protection, and vice versa. So at one time, you can use only one type of protection. So in order to stop to use the root protection, you have to stop the loop protection. So we go here and undo this command, undo STP loop protection. Then after that, we can use the STP root protection. So here we can display, and but unfortunately the protection type is none here. I think they have some wrong thing, because this should display the type of protection on the port. Okay. So what's about the protection of the BBDU? BPDU. PPDU protection. PPDU protection is not available here for the STP because that one PPDU protection is only enabled with the RSTP. So how to enable the RSTP? It's very easy. Just go to STP mode RSTP like that. So you can see here, RSTP is already enabled. Let me plug my power. We run out of the time, but I still need 5 minutes maybe to explain the other things. Okay, so here RSTP is already enabled. So if we want to, for example, go to this and we undo the root protection. Oh, it seems that everything is changed when we change the mode to RSTP. I think the configuration of STP is already clear. So here, if we display STP, maybe we briefly display. So we can see here switch number 1 is designated, port number 1, port number 2 is alternative, port number 3 is root. So based on this configuration, that means the manual cost that we configured is already there. So if we go to interface Ethernet 002, is it 002 last time? The one that we configured is 002, yes, 002. So here we can undo root, undo STP root protection, and we can undo loop protection as well. And we can set STP BPDU. Oh. I don't know. It seems not working. I don't know what happened. BPDU, VLAN, visual LAN. What's this? Oh, sorry. The yeah. I remember. The STP BPDU protection is actually for the whole switch, for the entire switch, like this. It's not based on an interface. So for every interface, we can run BPDU protection. Sorry, for interfaces, we can run the root protection or the loop protection. But for the switch, we can run the BPDU protection only. Okay, that's all about it. And if let's say we have one PC connected here for maybe for switch number 3, maybe like that. So this, let us start this PC. So this switch, for switch number 3, undo terminal monitor. So system here, we have to go, in this case, we have to go to this switch to port GE001. So interface GE001. Then we have to tell the switch that this port STP is an edged port. So we enable the edge port here. this command will tell the switch number 3 that the port GE001 is not participating in the STP, is not participating in the STP. So this is how to configure. Also, if we want to, for example, if let's say we have one switch like this switch, and this switch is only used to connect multiple PCs like that. For example, this one like this. So if the switch is only used for what they call it, PCs, so in this case, because this one is not starting, I don't want to waste time. I just going to show you the command here on switch number 3. So if this is the case, then we have to go to the switch and we enable the STP edged port default. So this command will turn all ports of the switch to the edged mode, to the edge port mode by default in one command. Okay, clear?
Clear, but what?
What's the question?
What does the command do?
This command, the last command.
Yes.
This command will turn the switch, in this case, if the switch is connected to only PCs or maybe network devices that not supporting the STP, and that devices are not participating in any STP election. In that case, if we want to enable the edge port for all of these switch ports, then it's not easy to go to enter in every switch and to enable the STP edged port like this, because this command is going to enable the interface that you are in only. For this case, we will enable the interface 001 to be an edge port. But if you want to enable, for example, 48 ports together at the same time to be used as edge port, so what to do?
Oh,
You
edge
use
port
this default. Use this default command to change the entire switch ports into the edge port mode in one command. Otherwise, you have to go to every port and change it separately. Understood?
Yes, doctor.
Yeah. Any question, guys?
No, doctor, but can I take my leave because I am going to the mosque?
Yeah, that's fine. Is it open? I mean, prayers, is it allowed?
Yes, but it is according to the procedure that is that have been ordered by the government. It is that we need to take a turn and write our name.
And I think it's still not open for foreigners, is it?
It is now open and will be open. And will now be open more vastly.
Okay, inshallah. Also, we go to break. Yeah, thank you for the information. Okay, guys, if anyone doesn't have any question and want to leave, you just leave. If you have any question, please ask me now, quickly. Any question?
For now, no, doctor.
No.
No
But it's
questions.
yes.
Okay, last chance. Any question? I think the others are
No, doctor.
maybe sleeping. Only 4 students who replied. The others maybe join the group and they sleep. Or maybe do other stuff. Okay, hopefully everything is clear. And if you have any question, anytime you can drop it in the WhatsApp group, and I will do my best to answer, to help you, inshallah. Thank you for attending my lab, and hopefully everything will be clear, and see you inshallah in the next class. Also, please
Okay,
don't forget to check the Putra Plus, because I'm going to announce the requirements of the lab project. Okay.
Okay, Doctor.
Thank you. Thank you. Yes.
Thank you, Doctor.
Yes.
Thank you, Doctor.
Yes.
Doctor, regarding the mosque, do you stay near UPM mosque?
No. I'm in KL.
Okay, I think
Yeah.
the Masjid Jame already open for civilians.
Okay. Okay. Thank you.
Yes, but we need to queue up, I think.
Okay. No
Okay,
problem. Yeah. Thank you.
okay,
Thank
Doctor.
you.
Thank you.
Okay. Have a nice day, and see you inshallah next class.
See you.
Assalamu alaikum wa rahmatullah.
Waalaikumsalam, Doctor.